Hello everybody, we will start our lesson today. I will continue from the one I left over yesterday about absolute value inequalities. And this absolute value inequalities consists of two parts. One of them is the easy part, something that you have seen before. And after that we will do the harder part that you have not seen before. When I say you have seen that before, then it refers to your algebra 2. You have seen absolute value in this type of absolute value inequalities in your algebra 2. Okay, but before I go on, let me remind you that you have quiz 0 due this Sunday and quiz 1, 2, 3 due this Monday. Quiz 0 is your extra credit. That's super easy. Basically to teach you, to give you direction and hands-on experience on how to turn in your work. Your quiz 1, 2, 3 will do this Monday, and you will see my quiz 1, 2, 3 actually represent pretty much like 40% of your test 1 material. Okay, your test 1 coming this Wednesday, so how many days from now? 5 days from now. Okay, and your test 1 material will be chapter 1 up to chapter 2.6. Now, today I will take approximately half an hour to finish up 1.6. And for 2.1, that will be approximately 20 minutes. And then 2.2, I think I will spend approximately 1 hour. And then 2.3, I will spend approximately half an hour. Okay, and then if I will go to 2.4 after that. It's a quadratic. It's approximately half an hour too. And then on Monday, I will continue with 2.4, 2.5, and 2.6. That's the plan. Okay, let's start with the lesson then. Now, for part A, the easier part. There are two categories here. For C positive number, absolute of blah greater equals to, or let me do the less than equals to that C first. Okay, for example, absolute value of X is less than equals to, let's say, 3. Now, let's see the interpretation first. This means, and later on when you do your work, of course, you can skip this interpretation, just go ahead with the writing in black. Okay, but this means distance of X from 0 is at most 3. So on the number line, if you have 0 here, then you go at most 3 units to the right. That's how you get 3 there. And at most 3 units to the left. And that's how you see -3. Okay, now because of that interpretation, then we see the next line for this inequality will be this X must be between -3 and 3 inclusive. Okay, notice that that's for absolute value less than or less than equals to positive number. Okay, it has to be positive number. Now, what happened later on if it is 0 or negative? We'll take care of that later. Okay, but let's see first. How about absolute of let's say 2x minus 3 less than 4? Then how do we solve that? Our first step will be the same. Absolute of blah is less than 4. It means it goes less than this guy here, the blah, is less than 4 to the right, if it goes to the right, and less than 4 units to the left. Then from there we solve as usual. We add 3 to all 3 sides. This is 7 here, this is -1, and then divide by +2, so I don't need to reverse the inequality sign. Okay, now consequently, then the solution here will be -3 to 3 in interval notation, while here the solution will be parentheses -1/2, 7/2. Okay, now that's if the distance is less than or less than equals to a positive number, then this expression here must be in between two numbers. The distance is less than or less than equal something, then you can go at most, in this case, 3 units to the right and at most 3 units to the left. Now, what happens if we have negative number? Why then we separate negative number? We discuss negative number separately. Let's see, example 2. How about absolute of x to be less than equals to -3? Now the thing is, we know that absolute value of x always greater than or equals to 0, always. Right? So under no situation the distance of x from 0 will be a negative number. So we say this is no solution. Actually, even if I say absolute value of x less than 0, now less than 0 means it has to be negative. No, it won't happen. It's still no solution. Okay, now don't underestimate these two statements. I can make it look so fugly and you still get the same solution. Let's say if I have absolute of 3x squared minus 7x plus 10 less than equals to -1. Under no chance, under no situation, this guy here, under no situation that this guy here, whatever you get here, once you put absolute, it will be at least 0. Under no situation will be less than or equals to -1. So you will say no solution. Okay. The one that you need to be careful is when we have, let's say, let me use that question, absolute of 3x squared, let's say minus 2x minus 1 is less than equals to 0. Now you will see this statement is actually consists of, absolute of 3x squared minus 2x minus 1 less than 0, or that guy is equal to 0, right? Now the thing is, this is impossible. This is impossible. So the issue is actually with the equal sign. Okay, less than equals to 0, absolute value less than equals to 0 forces that absolute value to be equal to 0 only. So then it implies, if it is equal to 0, it implies that thing has to be 0. Okay, then you try to factor. I think this one is factorable. This is 3x and x minus 1 plus 1. So x equals to -1/3, x equals to 1. Now, what happened if we have the second case, the first case here for greater than, for less than equals to C. What happened for if we have less than equals to C? For a positive C, how about absolute value of blah to be greater or equals to that positive number? For example, the easy one first, absolute of x greater equals to, let's say, 2. The interpretation is that on the number line, the distance of that x from 0 should be more than 2. So more than 2 units to the right, start from 2 to the right, right? All the points here, any points that you click here, any point that you pick here, the distance from 0 will be more than 2. Okay? You pick a number here, let's say this guy. Okay? The distance will be more than 2 already. Now we need all those, all such position. Okay? But not only on the right-hand side, it is also possible that you go to the left. So all those x that has distance more than or equals to 2 from 0. That's the interpretation. Now, from that diagram, from that picture, then you will see that x is greater equals to 2 or x is less than equals to negative 2. Okay, so every time you see absolute of something greater equals to a positive number, the first line you write will be this line. Okay, then from there you write the interval notation. So it's either from negative infinity up to negative 2 union 2 to infinity. Now you can take a look on the red diagram there, how I get this interval notation. Now what I plan to do next, just like before, I will change this into other expression, other linear expression, and I will change this into other positive number, and I may use equal sign, I may not use equal sign, but it will be greater than. Suppose, for example, I have absolute of 3x plus 4 is greater than, let's say, 5. I randomly pick numbers. It means that expression 3x plus 4, this guy here, that guy there has to be to the right of 5 or to the left of negative 5. Right? That's the only time that 3x plus 4 will be will have distance more than 5 from 0. From that, we see that 3x plus 4 is to the right of 5, or 3x plus 4 is to the left of negative 5. Now then, I solve it as usual. That's 3x greater than 1, x is greater than third, 3x is less than negative 9, x is less than negative 3. So, less than negative 3, negative infinity up to negative 3 parentheses, because I don't include the negative 3, union, parentheses 1/3, because I don't include the 1/3, up to infinity. Okay. Now, I believe you have seen this before in Algebra 2. Okay. But make sure that you kind of like feel what it means. So draw these red diagrams in your mind. then at least in your mind, you don't need to do it on your test paper or your quiz paper. Just do it in your mind. Okay, the one you need to write are the one in black. Okay, the one that you need to write are the one in black. Now that's for the standard questions. Some strange question. What happens if we have 0? What happens if we have negative? Let's say, for example, absolute of 2x plus 3 is greater than negative 4. Now, we know that absolute of anything will always greater equals to 0, which automatically then greater than negative 4, right? For anything, always, this is always true. So the solution here will be all real number. Or you can also say from negative infinity to infinity. Now you can try, pick any x you like. Choose an x, you plug that in, you will get the correct statement. Okay, and in fact, this is still true even if you use equal sign here. Now, what happens if I use 0 instead? Then absolute of 2x plus 3, let me use 0 now, greater equals to 0. This is still always true though. This is still always true, right? Because absolute of anything, yeah, absolute of anything always greater equals to 0. So this is still always true. The answer is all real number. The difference is, what if, let me use a slightly different color, absolute of 2x plus 3 is greater than 0. This is basically positive but not 0. Positive but not 0. Which is always true except when it is equals to 0. Right? But this is always true, except 2x plus 3 equals 0. That's when it is wrong. Okay, so the next step for this, if you have this situation, it will be the situation where 2x plus 3 cannot be 0. That's the only thing you need to avoid. 2x plus 3 other than 0, when you do absolute value, it will be positive. Okay, so 2x cannot be negative 3, x cannot be negative 3 halves. The solution, therefore, is all real numbers except negative 3 halves. You can plug in any x you like and it will make this statement to be correct. Except when you plug in negative 3 halves, it will make that statement become wrong. Okay, now we can also write this here. If we try to visualize this, let's visualize this first. This is basically the whole real number except that one number you need to avoid. So everything to the left and everything to the right is okay. Just that negative 3 halves need to be avoided. So in interval notation, that will be the interval on the left-hand side. If you want to write that in the interval notation, union the interval on the right-hand side. This is how you have to write the interval notation when you skip that one point. Okay, when you skip that one point. Now, however, I still prefer, if you have a choice, you can write it. You can write your solution this way. Okay, I actually prefer this one, but you can also write your solution this way. Okay, now that's for the easy part. Now let's do some problem from a book. The problems in our book actually on the easy side. Yeah, it tends to be on the easy side. Let's say, for example, number 19. I plan to take only half an hour for this. It seems like no, it takes more than half an hour. Number 18 instead, not 19. Number 18, absolute of x minus 4 is less than equals to 0.03. Then the first thing you say, this is case number 1. So that x minus 4 has distance less than equal to 0.03 to the right or to the left. So when you add 4, you get 3.97 less than equals to x less than equals to 4.03. In interval notation, it will be 3.97 in bracket up to 4.03 also in bracket. Number 20, what happens if you have other things get together? Isolate the absolute value. 2 absolute of negative 11 minus 7x minus 2 greater than 10. So 2 absolute of negative 11 minus 7x greater than 12. You see my inequality sign, I still keep them straight, just like in equal sign, in equation. And then I divide by 2. Now notice that now my absolute value is isolated, right? Once it is isolated, then absolute of blah greater than 6, then that blah must be to the right of 6. That blah must be to the right of 6 or to the left of negative 6. Okay, so that's negative 7x greater than 17. X is less than negative 17 over 7. See, I reverse the inequality sign because I divide by negative 7, right? And then the one on the second branch, I have negative 7x is less than 5. X is greater than negative 5 over 7. Again, because I divide by negative 7, I reverse the inequality sign. So the final answer is either x is to the left of that negative 17 over 7, which means this is the interval rotation, union to the right of negative 5 over 7. That's the interval notation. Then how about number 26? Number 26, we have this strange thing. You have never seen this problem, I know. Right? But I don't even call this a hard question. You never see this problem before, I know. If I don't give you any example, there's a chance that you say, Thomas, you never taught us that. But I actually did. Notice that this is a compound inequality, right? If you actually clueless how to do this, and there's no other way in this case, then what you can do is you tackle this inequality and this inequality separately. Okay? That's how we will do it. Okay, so the first case is when absolute of x is greater than 1 and absolute of x is less than 5. Okay, absolute of x greater than 1 implies x is to the right of 1 or x to the left of negative 1. And x is between negative 5 to 5. Now let's try to picture what this means. The first one is, it is to the right of 1. Let's say this is 0. To the right of 1. I'm sorry, it should be parentheses. Right. To the right of 1. Or to the left of -1. That's when we need absolute of x to be greater than 1. Now then the second requirement is that x is between -5, that x is between -5 to 5. Now which part is double shaded? The part that is double shaded is this part here and this part here. Okay, so the solution will be -5 to -1 union 1 to 5. So basically you see that compound absolute value inequalities as two absolute value inequalities that you need to solve simultaneously. Okay, simultaneously. Now that's the easy part. I know it seems to be hard at first, right? But that's basically review of what you have before though. Now the harder part is when the other side has a variable. So 1.4b harder part. And you don't see this in your textbook. So if you rely on your textbook only, you won't be able to answer this kind of question. But you also see in my I think in my take home, my quiz 1 to 3, I think you see this one question there. For example, how do we solve the question that I showed you yesterday, absolute of x plus 2. Yesterday we have equal to 2x minus 1. That's what we had yesterday. Yeah, that's what we had yesterday. The way we solved that was we say, for x greater equals to -2. Now that's because x plus 2 greater equals to 0, right? This guy is greater equals to 0. Then we can take off the absolute sign for free because the guy inside the absolute sign is positive or 0, and then we solve it from there. And then for x less than -2, that's basically when x plus 2 inside the absolute value is less than 0. Then we will get negative of x plus 2 equals to 2x minus 1. Yesterday we did it this way, so we get x equals to -1/3. But then don't forget, yesterday we also need to check x is greater equals to -2. Is the answer here 3 greater equals to -2? That's true. So this solution checks. Okay, while the one here, x less than -2, is -1/3 less than -2. That's not true. So I have to cross it out. Okay, so the final answer is x equals to 3. Now that's what we did yesterday. What we will do today is applying the same idea. Suppose I have, so example 1 star, absolute of x plus 2 greater than 2x minus 1. then we break it up like this. For x greater equals to -2, again, that's when x plus 2 is positive. Now, when this guy is positive, the guy inside the absolute value is positive, then we can take off the absolute value for free. So basically, we then can say x plus 2, so maybe I say right? So x plus 2 is greater than 2x minus 1. 3 is greater than x. Basically, so x is less than 3. Now you combine that together with this. Greater equals to -2 and x less than 3. So for this branch here, you get the x is less than 3, but it also has to be greater equals to -2, right? So for this branch, the solution will be -2 up to 3. But we are not done yet. The other possibility is when the x is less than -2. So what happened is the x plus 2 is negative. Because the guy inside the absolute value is negative, then absolute of that guy must be the opposite of x plus 2. Negative x minus 2 greater than 2x minus 1. So that will be 3x here. This will be -1 here divided by 3. So x should be less than -1/3. Now, together with this, x has to be less than -2, but at the same time, it also have to be less than -1/3. So if on the number line, if you imagine that it has to be less than -2 and also less than -1/3. Since it has to set aside both of them, then the only way that both of them can happen, let me shade them, less than -2 and less than -1/3, one-third. So you see which part is actually double shaded. So the solution from here will be this x has to be less than -2. Okay, so you get -infinity less than -2. Overall, therefore, let me use therefore instead because I summarize the summary. Therefore, the solution is -infinity up to -2 union -2 up to 3. Oh, hold on. But this two interval is actually connected though. Yeah, this guy here is connected to this. See? One of them with bracket, one of them with the parentheses. So in other words, one of them from -infinity up to -2, not including -2. But then the second part is you include -2, go to 3. Right? So I can actually sew them together. Yeah, you put them together. Or simply, see, I made a mistake there. I should not use bracket here. That will be -infinity up to 3. How do we interpret this inequality actually? How do we interpret this inequality? Now, to interpret that, we basically will see later on, for this to happen, basically it means the graph here, the graph of this blue one should be above the graph of the green one. what are the axes? Maybe I reword. What is the interval of x when the graph of absolute x plus 2 is above the graph of 2x minus 1. Now the thing is, in this class, I don't let you use graphing calculator, okay? Because graphing calculator will give you the picture, but will not be able to give you the exact solution. But at least it helps us with the interpretation, right? So let's see what the graph look like. I think we did this before. Y equals to the absolute of x plus 2, that's the graph on the left hand side, the graph that we want to be above, right? And then this is the graph for 2x minus 1, the graph that we want to be below. Now you see that the graph of the purple graph, the absolute of 2x plus 2, the absolute of x plus 2 is always above the red graph all the way up to 3. So let me put this graph here. Put it back to our notes. So you see, this is the graph of absolute of absolute of x plus 2. And this red one here refers to the graph of 2x minus 1. Now you see that the blue graph is above the red graph in this interval up to 3 all the time here. For any x there up to 3, the purple graph, the absolute value graph, is above the red graph. Okay? Go this way, then you can see it better. But the way we argue that is we need to break the situation into 2 parts. We need to see that as, let me erase this because it's way too overwhelmed. We need to break it into 2 parts, the case for x greater or equals to -2 and the case for x less than -2. Okay, now this is the way you do absolute value inequality when you have variable on the other side. Okay, when we have a chance, I think one day later on, I will show you a question in which you have 2 absolute value. But for that to happen, in the past, let me tell you what I was referring to. I'm referring to this type of question. Suppose we need to solve absolute of x plus 3 plus absolute of x minus 2 to be greater equals to, let's say, 7. Now, then how will you do this? Now you see that if we look at the number line, the sign of this guy here change at -3. While the sign here, the plus minus, change at 2. So you need to actually work it out in 3 cases. The first case is the one greater equals to 2. So for x greater equals to 2, that's one case. And then the second case is when x is greater equals to -3 but less than 2. And then the case for x less than -3. Let me just work it out. Let me just work it out. But you need to actually master those what I did above first. Okay, you need to master those first. So the first case for x greater equals to 2. Now, if x is greater equals to 2, what happened to x plus 3? You see, when x is greater equals to 2, when you add 3 both sides, there will be at least 5, which is greater equals to 0. Which means that x plus 3 is greater equals to 0. Right? Now, likewise, x is greater equals to 2 implies x minus 2 is greater equals to 0. So, that absolute x plus 3, because in this interval, x plus 3 is positive or 0, and x minus 2 is non-negative, then I can remove the absolute value for x plus 3 and also for x minus 2. So 2x plus 1 greater equals to 7, 2x greater equals to 6, x greater equals to 3. And we combine this greater equals to 2 and greater equals to 3. It has to be greater than 2, greater equals to 2 and also greater equals to 3. So in this interval, we get at least 3. Right? At least 3. Yeah. Let's take a look on the number line there to help us. So it has to be at least 2 and also at least 3. Now see which one double shaded. Right? Okay. Now what happens if it is in the middle interval? So x is between -3, including -3, but less than 2. So if x is greater equals to -3, it means x plus 3 is greater equals to 0. But because x is less than 2, it means x minus 2 is less than 0. Okay, this guy here, and this guy here. So go back to the original inequality. In this interval, x plus 3 is non-negative. So I will take the absolute sign as usual. Nothing changed. However, x minus 2 is negative. So when x minus 2 gets out from the absolute sign, I need to put negative of that at x minus 2. Then when I combine like terms, x plus 3 minus x plus 2 greater or equals to 7, I get 5 greater or equals to 7. That's a contradiction. So no solution in this interval. No solution in this interval. The last section. So you see, this is a question that you cannot do just like, oh, you know what, just do it this way. Oh, just do it this way. No, no, no. Welcome to pre-calculus. Welcome to pre-calculus. Sorry, it should be less than negative. That's the third case. Yeah, this case here. So this is my case 1. This is my case 2. This is my case 3. So this is my case 1. This is my case 2. Now my case 3. So when x is less than negative 3, then x plus 3 will be negative. And because x is less than negative 3, so x plus 2 will be less than negative 1, which is less than 0. So that implies x plus 2 is negative. So if I go back to that initial inequality, then I need to, when I try to get this x plus 3 out from that absolute sign, I need to put another negative to make it positive. Well, because x plus 3 in this interval is negative. To make it positive, I slap that with another negative. Likewise here. Then I get negative x minus 3 minus x plus 2 greater or equals to 7. So negative 2x minus 1 greater or equals to 7. Negative 2x greater or equals to 8. X is less than or equals to negative 4. So you see that first it has to be less than negative 3. Okay, but it also have to be less than negative 4. So you see the overlap will be here, right? So the interval will be negative infinity to negative 4 bracket. The overall solution, therefore, the solution is negative infinity up to negative 4, or from what is it from A? Yeah, from part A, I mean part 1, right? Yeah, part 2 has no solution. Okay, so no, this is not a short question. This is the type of question you will see not only in my test, but also the type of question you have in your calculus class. Okay. Yeah. No easy solution. No, it's not something that you look at that you know the solution right away. No. You need to show work, and that's the only way for you to get this the answer. Okay. But at the same time, don't say, "Oh, Thomas, you make it so hard." No. Calculus is hard. Pre-calculus is hard. We never say it would be easy. Whoever say pre-calculus is easy, that person never take my class. And that person actually not prepared for calculus, except for easy calculus teacher, right? But no, you are not preparing yourself for easy calculus teacher only. you are preparing yourself for any calculus teacher that you may need to take. Okay, so yes, there are still teachers who is considered hard, but you learn actually best from teachers who are appropriately hard. Okay, the one that is easy, they are the one who actually disable you from moving forward. Okay, now that right now is 12 o'clock. I will end this section by giving you a break.
I do like this, Papa.
We have done with 1.6. I call that part B. Now I go to 2.1, which actually we have done on the first day of class. Okay, in this 2.1, we learn about distance formula, and midpoint formula. Yeah, we have learned these two. Just to review a little bit, the distance formula. The distance d of point P, let's call that x1, y1, and point Q, whose coordinate is x2, y2, is given by d squared equals to x2 minus x1 squared plus y2 minus y1 squared. Now the one in our textbook, they go on doing the square root of that. Because it is distance, then it cannot be negative. That's why we only take the positive branch. Okay, now distance, that's distance formula. Then the midpoint formula. The midpoint M of point P, x1, y1, and point Q, whose coordinate is x2, y2, is given by M equals to the midpoint of x1 and x2, comma, the midpoint of y1 and y2. Don't forget, you have to memorize these formulas. We did examples already, the easy ones from on the first day of class. Now today, I will go over more in-depth pre-calculus level problems. For example, on that section 2.1, number 24. Number 24. Find the perpendicular bisector. Bisector of segment AD. Where the A is -3, 2. The B is 5, -4. Okay, I will go back to this question later on once we are done with 2.3. Okay, so I think after this I will do 2.3 first, and then I go back to 2.2. But what is the idea of this question? Now the idea of this question is the following. Suppose I have point A here and point B here. And we have a segment connecting these 2 points. Now, perpendicular bisector is the line that separates this segment into 2 parts. It's a line that bisects that segment perpendicularly. Okay, so the question is, what is this? Now notice that if you pick any point on this blue line here, the perpendicular bisector, you pick any point, random point, then you will see the distance of this point to A is the same to the distance from this same point to B. Okay, let me pick another coordinate again here, let's say. Right, now notice that the distance from this point on the blue line to point A is the same to the distance of that same point to point B. Okay, now we want to find the equation of this line, which is the perpendicular bisector of this segment. Okay, that's what we are looking for. Now, how to do that? The first method that relates to what we learned in this section is because any point on that blue line, that blue line has the same distance to A and to B, then let's say let the coordinate xy be any point, a point on the perpendicular bisector. Now the distance from that coordinate, let me call that coordinate P, to A should be equal to the distance from that coordinate P to B. What is the distance from coordinate P to A? That will be the square root of x minus x plus 3 squared plus y minus 5 squared. While the distance from coordinate P to B will be, I'm sorry, it should be 2, not minus 5. I was looking at the wrong coordinate A. So this is minus 2 here. So P to B will be x minus 5 squared plus y plus 4 squared. Now notice that both of them square root, right, without negative part. So I can safely square both sides without being afraid of the negative part. So I square both sides here too. Actually, at this point, we still don't know if the resulting curve later on will be the blue line. Okay, now visually we saw it should be a line. Okay, but using what we do here right now, we still don't know. We still don't know if that will be a line. Now you will see the x squared on the left-hand side later on will cancel the x squared on the right-hand side. Likewise, the y squared on the left-hand side will cancel the y squared on the right-hand side. Okay, but for now, we don't know that yet. We just do the algebra. The thing is, in your pre-calculus class, you need to be patient. Don't rush to the answer and sacrifice the detail, okay? Because if you cannot show the work properly, you simply don't know what happened in between. and your final answer will be very questionable. Okay, now notice that my x squared cancels that one here, and then my y squared cancels the one here. Now then I will get 6x plus 10x minus 4y minus 8y equals to 25 plus 16 minus 9 minus 4. I'm supposed to combine like terms first, the constant, right? Okay, but I just put them together right away. So then you will see I get 16x minus 12y equals to, what is this? 28. Oh, by the way, each term is multiple of 4. So let me divide by 4 to simplify that. So I get 4x minus 3y equals to 7. So the equation of that line is given by this. If you want to, this is, by the way, is standard form. Okay, you can change it into slope-intercept form if you want. Okay, but as long as it is either in standard form or slope-intercept form, you are actually fine. Okay, now the other question that I think is quite reasonable for us to work on is number 30. Yeah, these questions here cannot be done yet when we did our distance formula and midpoint formula at that time, because we have not learned solving equations properly. Okay, at least I didn't assume that from you. But once we finish solving equation yesterday, then we can actually put more flavor into what we learned before. Number 30. Find all points. Find all points with coordinates a, comma a, that are distance free from P, which is negative 2, comma 1. Find all points with this coordinate form, distance 3 from P. Okay, so the distance formula is square root of a plus 2 squared plus a minus 1 squared, right? This a here and this a here. And the distance has to be 3. Okay, now let's work it out. I square both sides, I get 9. And what I will do next is to FOIL this. Get a squared plus 4a plus 4 plus a squared minus 2a plus 1. Set one side equals 0 because I plan to solve it by factoring. Both of them, all terms are actually multiple of 2. So let me reduce the equation by 2. I get 0 equals to a squared plus a minus 2 So this is a equals to -2, a equals to 1. So the coordinates are -2, -2, and I'm sorry, 1, 1. Another way to interpret this question is actually as the following. Okay, so suppose I have a circle centered at -2, 1. So -2, 1, let me put it here, -2, 1. And the distance is 3 units. I try to make it 3 units now. 1, 2, 3, approximate here. Let me try. Let's say something like this. Okay, let's say something like this. Not a good picture, but approximate. I do approximation there. Now then, I want to find a coordinate on that circle that has a form a comma a, which if you think about it, that's actually a comma a must be the coordinate on y equals to x. You know, the coordinate on y equals to x. Okay. Now notice that my graph was not precise, right? But I hope this gives us the idea that one of the coordinates is here. That's our 1, 1, and the other coordinate is here. That's our -2, -2. Okay. So I will do exactly the same work if the question were, if I rewrite the question as find the intersections of the circle centered at -2, 1 with radius 3 and the line y equals to x. Okay, because y equals to x, equation of the circle centered there is x plus 2 squared plus y minus 1 squared equals to 3 squared, which is 9, right? Now then, because x equals to y, then I replace the y by x. And when I solve it, I will get x equals to -2, x equals to 1. So the coordinate will be the same solution we had earlier. Okay. Now, the thing is, when we work on this problem, number 30, our textbook has not talked about equation of a line. That's why they cannot ask you the way I just did. Okay, but we did that on the first day of class, so right after this, we can actually do that problem. Okay, the last one before I move to the next section, which I plan to do 2.3, number 32 in this textbook on section 1.1. Let A be 2, 0 and B be -2, 0. Find a formula or an equation that expresses the fact that the sum of the distances from P, X, Y to A and to B is 5. So in other words, find the equation of all coordinates whose distances to A and to B add up to 5. Let's visualize that. Let's visualize that first. So I have this coordinate system. I have 2, 0 and -2, 0. Now you need to find all those coordinates. You need to find all those coordinates such that the distance of that coordinate P to A and to B add up to 5. Let's call this distance 1 and this is distance 2. Now what we want is distance 1 plus distance 2 equals to 5. That's what we want. Okay, we want to find all such coordinates. Now what is distance 1 first? Distance 1 is the distance from coordinate P to A. Plus the distance from coordinate P to B. And that has to be 5. Now here I will have the square root of x squared minus 4x plus 2 plus y squared. I'm sorry, plus 4 is supposed to be plus square root of I actually not supposed to distribute that, but let me just distribute that. X squared plus 4x plus 4 plus y squared equals to 5. Oh man. Oh man. Then how do we solve these? Now, what we will do is we will isolate one of the radical. So you see that for you to be able to do this, you should have practice from yesterday. Now, I see, to be honest with you, I see from your activity how much time you spend online with me and somehow see how much time you spend in doing homework is actually quite minimal. It's actually quite minimal. Please do your homework though, okay? No, please don't think that you can survive this class by just being smart. No. You can be smart but still not passing this class. Okay, you need to practice. Okay? It's one thing about having a good brain. It's one thing about having a smart brain. It's another thing to fill it up to what you need to learn. Okay, you can be smart. Okay, but if nothing in there, I still call you empty head. I mean, that's what it means, right? Okay, it's not that you don't know how to use the brain, but you have nothing to use. Okay? And I don't want that kind of students to be in my calculus class. You don't want to be that kind of student. Okay, it's not about me, it's about you. You want to be someone who can handle math problems. And that's why you take the calculus problems, and that's why you take this class. Okay, so please practice though. The only way you have something in your brain to think about, to work on, is when you actually put something in there. Okay, trust me, smart people do study. Oh, Thomas, I'm not that smart. Then it makes you need to study even more. Okay, no, either way you need to study. So if you are smart, you will study. Okay, if you are not smart, you will study even more. Under no case you won't study. Okay, it's one thing, like what my illustration earlier, you can have a smart brain and you may not have a smart brain. That's actually not an issue. Right now you need to fill something in there with your pre-calculus. Okay, and smartness only means that you have a faster machine. Okay, if you are not smart like me, which I don't think I'm smart, okay, it simply means that it will take me longer time to do a certain problem. But I still can speed up by practicing. Okay, but if I don't practice at all, then I have nothing in my brain, and my professor will correctly call me empty head. Okay, because nothing in there that we can use. Okay, I tell you this right now so that you don't go to this direction. I'm not saying that you are this kind of person. No, that's not what I'm saying. What I'm saying is, okay, if you want to make it feelable, if you want to make your brain has something that you can use, you need to first put something in there. Okay, so please practice. Please practice. Now I will then square both sides. And on the right hand side here, when I square both sides, it will be, yeah, it's quite nasty, I know. But welcome to pre-calculus class. So I get x squared minus 4x plus 4 plus y squared equals to 25 minus 10 square root of x squared plus 4x plus 4 plus y squared plus the square of that thing. Now, I hope you see how nice it is right now that we have so many things cancels. You see that we can cancel the x squared here, right? We can cancel the 4, let me double strike that here, and I can cancel the y squared here. Right? Okay, so let me rewrite it first so that we have better view. Negative 4x equals to 25 minus 10 radical x squared plus 4x plus 4 plus y squared plus 4x. Now what I will do next is I will move this guy here because it is negative term, right? I will move it to the left hand side to make it positive. Likewise, this guy here, I will move it to the right-hand side to make it positive term. So then I will get 10 square root of x squared plus 4x plus 4 plus y squared equals to 25 plus 8x. This 8x is actually coming from 4x plus another 4x. Now to get rid of that square root, I square both sides again. When I square both sides, the 10 becomes 100, the square root becomes without square root, and on the right hand side I get 25 plus 8x squared. So remember the principle that we isolate the radical, right, and then square both sides. The purpose is that when we square it, it gets easier. This is 100x squared plus 400x plus 400 plus 100y squared equals to 625 plus 400x plus 64x squared. Then 100x squared minus 64x squared, right? So I move this to the left. Oh, the 400x cancels, huh? Lucky us. Plus 100y squared. And I will then move my 400 to the right. So I get 625 minus 400. Then I get 36x squared plus 100y squared equals to 225. Wow, that's a long question, huh? Again, I can only say welcome to Pythagoras class. Okay, now addition suggested homework from this 2.1. I already asked you to do some problem from here, but I would like you to do more. I would like you to do number 23 and number 27. Number 29. Number 33 will be interesting, but don't worry too much if you are not able to show that, to work it out. Okay, I should call this 2.1b because we did some problems already the first day of class. Now let me go on to 2.3. 2.3 is on lines, which you have seen in your Algebra 1 and also your Algebra 2. And we have done a little bit, right? We have done a little bit on the first day of class. Now here we will see the slope. We have done that. Okay, and we have seen equation of the line. We also done that already. Okay, let's say for example, find and sketch. Find the equation and sketch the line containing P is 2, let's say -3 with slope equals to, let me pick some ugly number, -3/4. We know the slope, we know the coordinate. So part A, the equation, because the slope is -3/4, it must be y equals to -3/4 x plus b. And to find the equation, I need to find the b. We will find the b by plugging in the coordinate p. -3 equals to -3 4 times 2 plus b. That's -3 equals to -3 over 2. I cancel the 4 and 2, right? And then -3 plus 3 half equals to b. Do the LCD. Then when I add, I will get -3 halves equals to b. So the equation is y equals to -3 for x minus 3 halves. That's the equation. Okay. Now, how about the sketch of the graph? How about the sketch of the graph? Now, let's say, let me give the, give me a second. Let me grab a graphing paper. How do we sketch that? Okay, so let's say this is our graphing paper here. This is, to answer part B. Now coordinate P is 2, -3, 2, -3, 2, -3. This is the coordinate P. That's coordinate P. 2, -3. And then the slope is -3 over 4, which means the line has the tiltness, the steepness of -3 over 4. That's rise -3 over run 4. So -3 over 4. Okay, so the other coordinate on that line is this. The other coordinate on that line is this. And we can repeat that again. Instead of going down 3, I can go up 3. Up 3, back up 4. Up 3, back up 4. So the other two extra coordinates are on these coordinates here. Now then, once you put those coordinates, you can draw the line now. Okay, so approximately the line is this. Okay, that's the line containing P with slope -3, 4. So down 3, run 4, or up 3, back up 4. Up 3, back up 4. Okay, now I did that again here, up 3, back up 4. The slope is still 3 over -4, right? So you can see that -3/4 as 3 over -4 or -3 over 4, but not -3 over -4. Yeah, because -3 over -4 is positive 3/4. Okay. Now, extra stuff. We see the following. I think I want to write this down. A vertical line. Special cases. There are two special cases. The case when we have x equals to constant. Let's say, for example, x equals to 2. Let's say, for example, x equals to 2. Let me grab my picture. X equals to 2 refers to all the coordinates where the x equals to 2, as long as x equals to 2, as long as x equals to 2, right? Now, that refers to the lines that looks like this. This is the line x equals to 2. Sorry, I lost the connection earlier. Okay, I continue. That's a parallel to the y-axis, and then it has x-intercept, but no y-intercept. Okay. Now the thing is, all these four guys here always come together, always come together. So once you know one of them, you know all three, the other three. In fact, we can say even more that a vertical line has no slope, or another way to say it, the slope is undefined. Okay, the slope is undefined. Let me go back a little bit there, earlier question. Now remember we said that this form here is called a slope-intercept form, okay? Because the constant, the b, this part here tells us the y-intercept. It tells us the y-intercept. Yeah, you can try when you plug in, if you want to, if I ask you what's the y-intercept, we know every y-intercept must have x equals to 0. When x equals to 0, the y will be -3/2. Okay, again, every y-intercept, x equals to 0. If I ask you 100 questions of y-intercept questions, then you will set the x equals to 0 100 times. In other words, you do it all the time, the same way. Okay, and intercept is a coordinate, so it's not right for you to say the y-intercept is -3/2. No, 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 no. The y-intercept is not a number. Y-intercept is a coordinate. Just for variation, how about if we want to find the x-intercept, then we set the y equals to 0. And then we will solve this. I think what I will do first, I will multiply by the LCD to help me out. So multiply by 4, I will get -3x6. So 6 equals to -3x, x equals to -2. So my y-intercept, my x-intercept is -2, 0. If you look at that, you can see that here, this is my y-intercept. Boom. Right? And then this is that's my x-intercept, and this is my y-intercept here. You see that here? Right? Of course, I used a graphing paper earlier to have it a lot more accurate, and I can point to you how my graph supposed to be in line to be supposed to be to confirm my computation algebraically. So one thing you need to be able to do in pre-calculus, and I know this is a hard skill, but that's what you really need, is to be able to see the problem visually, geometrically, like what I did in part B here, and algebraically, like what I did here. Okay? Yeah. That's to find x-intercept and the y-intercept. Now, going back to these special cases, for x equals to constant, and you will have a vertical line parallel to the y-axis, has x-intercept but no y-intercept, and has no slope. Part B. How about y equals to a constant? For example, when we say y equals to -3, I just pick random number to help us visualize that. Y equals to -3. So y equals to -3 is the line at which the y component has to be -3. As long as the y is -3, you count that coordinate in. These are all the points, some of the points that has y equals to -3. So you will see, if I connect those points, I will get these horizontal lines. So y equals to constant will give us horizontal line that is parallel to x-axis. Okay, it has y-intercept. This is the y-intercept in this case, right? But it doesn't have x-intercept, but no x-intercept. How about the slope? The slope is 0. You do move to the right, you do the run, but there's no rise, you don't go up, you don't go down. Okay? Then you will see that horizontal line actually has slope 0, no increasing, no decreasing. Okay. Now we have done plenty of stuff here, but let me put one more flavor before I give myself a break. These things. Note. And we will do this after break. We'll do this after the break. Line 1 is parallel to line 2 if and only if the slopes of the lines are the same, yet the y-intercepts are different. If they have the same slopes and the same y-intercept, then those two lines are identical. They are not parallel. Yeah, two lines are parallel if they have the same slope, but they don't intersect at all. Okay, the slopes are the same. So the slopes here and the slopes here are the same. Equal, but no point in common. Actually, a little observation says that once two lines have different slopes, they must intersect. Okay. But another special case is when two lines are perpendicular. That's if and only if the slopes are negative reciprocal. The product of the slope is -1. Or another way to say it is the slope of one line is negative reciprocal of the other one. Okay? The product of the slope should be -1. Okay. Now I will give myself a break. After this, we'll do a little problem and then move on to 2.2. Okay. Okay. Let's continue. Let's put some examples into this. For example, let's say line 1 is 3x plus 2y equals to 5. Line 2 is parallel to line 1, and line 2 contains, let's say, 4,5. Maybe 4,7, so that we don't have too many 2 5s. Solution. The method I show you here is the method from algebra 1, actually, in the beginning algebra. So what I do is I try to find the slope for line 1 first. And then basically I isolate the y by itself. So the slope from line 1 is -3/2. Oops, no x. Now, then because line 2 is parallel to line 1, therefore the slope of line 2 must be equals to the slope of line 1, which is -3/2. That gives the equation to be of line 2 to be -3/2 x plus some d, right? It won't be, it's not the same y-intercept here. In fact, not supposed to be the same. Not supposed to be the same, because then they are not parallel. Instead, they are perpendicular. Okay, I'm going to write it there. Not equal. Okay. How to find that b? And then I plug in 4,7 into that equation. The y is 7. The x is 4, and we need to solve for b. So b equals to 13. Therefore, the equation of the line is y equals to -3/2 x plus 13. We are actually done here. We are actually done here for the equation of line 2. Now, however, it is a custom that if we start with general form, our textbook called this general form, then our answer should be in general form too. Okay, in fact, very soon you will see a reason why we want to keep that in general form. Okay, the reason I want to keep that in general form because of the following. Imagine if I try to change this into general form, then I will get 2y equals to -3x plus 26. I multiply both sides by 2, or the whole term by 2. And then I move the 3x to the left-hand side. Now, compare that to line 1. Compare to line 1, which is 3x plus 2y equals to 5. What I want to say is this. The general form of two parallel lines will be the same except at the constant. okay? But the other parts are the same. Okay? Now, in other words, the alternative way to do this problem, is the following. And once we know that line 2 is parallel to line 1, then the equation of line 2 must have the same structure to the equation of line 1, except the constant part. Now then, how to find that constant part? You plug in 4, 7. That's 3 times 4 plus 2 times 7 equals to C. 12 plus 14 equals to C. 26 equals to C. Therefore, the equation of the line is 3x plus 2y equals to C. Equals to 26. Way faster. Welcome to Precalculus. Now, suppose I go another way. Suppose I have another example. I have my line 1 is 3x plus 2y equals to 5. And my line 3, to distinguish that from line 2, is perpendicular to line 1. And line 3 contains, let's say, let me use the same one, 4, 7. So you have one line, let's call that line 1. Let's call that line 1. Okay, and then line 3 perpendicular to that and contains that 4, 7. Okay, so it's perpendicular here. Now then, what is the equation of line 3? Solution. Known from above that our line 1 was modified to be y equals to negative 3/2 x plus 5/3. I'm sorry, 5/2, not 5/3. Now, therefore, the equal by line 3, because it's perpendicular to line 1, then the slope of line 3 must be the negative reciprocal. Maybe I'll slow down a little bit. That's negative 1 over negative 2/3. Right? But you can just say that what is the opposite of negative? That's positive. What is the reciprocal of 3/2? It's 2/3. Okay, so you change the sign, negative becomes positive, or in other case, positive becomes negative, and then you flip the number. Okay, now then my line 3 now must have this equation, y equals to 2 over 3x plus b. Now plug in 4, 7. Now we are interested in finding the y-intercept here, the b. So I get 21 over 3, that's my 7, minus 8 over 3 equals to b. My b is 13 over 3. So the equation of line 3 is given by y equals to 2/3 x plus 13 over 3. So we are actually done here. Okay, but again, it is a custom because the original equation of line 1 was given in general form. So we go on changing this into general form. 2x plus 3y equals to 13. Multiply by -1 so that the coefficient of x is positive, right? Then this is the general form. Now I want you to compare these two line 1. The structure of line 1 is 3x plus 2y equals to 5. Notice that if two lines are perpendicular, then the format will have this. You will switch the x and y, the coefficient of x and y, and change one of the sign. So you can imagine this. Okay, 3x plus 2y equals to 5, right? Okay, now that's my L1. Then my line 3 will be, I will switch the coefficient and change one of the sign. Now then, how do we find the C? Again, I plug in the coordinate. So line 3 will be 2x minus 3y, I'm sorry, it should be y here, equals to -13. Okay, that will speed up our computation by big time, instead of by realizing that pattern. So in the test, Thomas, can I do it regular way? Yes. Can I do the shortcut way? Yes. But you still need to show the work. Okay. In other words, if I ask you this question, then you need to show at least this work here. Okay. Now in 2.1, we have a bisector, perpendicular bisector problem. What's that? Which I want to go over with you again using another technique. Copy this into down to last copy this to So that's the question we get from 2.1. Like what I said earlier, we have point A here, that's -3/2. Point B here is 5, -4. Now the perpendicular bisector must be the line perpendicular to that, right? Okay, but going through the midpoint. Okay, this is the midpoint of A and B. The slope must be negative reciprocal, but going through the midpoint. Okay, so this perpendicular bisector here is the line perpendicular to segment AB and contain the midpoint. Okay, then how to find that line? We need to find the slope. Let's find the slope for AB first. The slope for AB will be y2 minus y1 over x2 minus x1. So the slope of the perpendicular line must be 4 over 3. Right? That's from the slope point of view. How about the midpoint? The midpoint will be x1 plus x2 over 2 for the x component, y1 plus y2 over 2 for the y component. That's 1 comma negative 1. Now we put them together. So y equals to, maybe I use blue color so that we can see better. The blue color, y, so the perpendicular bisector line is given by y equals to 4/3 x plus b, and to find the b, I need to plug in 1 comma negative 1. Okay, 3 over 3 minus 4 equals b. So my b, let me continue here, my b is negative 7 over 3, therefore y is 4 over 3x minus 7 over 3. Okay, or if I want to make it nicer, move 7 to the other side, move 3y to the other side. Okay, now suggested homework for this section here, suggested homework for 1.3, I mean 2.3 will be, and I assume that you already did some of them, okay, but I would like you to do number 21 to number 37. Just do the odd ones as always. Now in 2.2, we have learned part of that 2.2 graph of equation. Part of that graph of equation is equation of a circle. I think that's the last part of this section. I think that's the last part of this section. Equation of a circle, which we have done. We have done this. Okay. Things that we will learn here. The first one is, I think that's what I will do here, is basic graphs. Or maybe to be more precise, graph of basic functions. Graphs of basic functions, or I should say basic equations. What are the basic equations I need you to be able to do from here? I need you to be able to do the equation of y equals to absolute of x and y equals to x squared and their transformation and their, I should say, translation. Basically, what if we move them to the left, to the right, up, down? And then the second thing we will learn from here is finding x and y intercept, which is on the easy side. Finding x intercept and y intercept. That's basically solving equations. And the third one is symmetry, reflection, and symmetry, which we may need to do on Monday. Okay, but at least the last part already done. The equation of the circle is already done. Now, basic equations, graphs of basic equation. In total, you will need to memorize the graph of 4 basic equations. So on Monday, you will learn another 2. The first one is the graph of y equals to absolute of x. The graph of, maybe I use blue color. The first one is y equals to absolute of x. This one you have to memorize. But I believe you also know it already, so nothing really to say to memorize. The graph of absolute of x is a V shape, 45 degrees to the right from the origin. And 45 degrees to the left. So it looks like this. Okay, now notice that the vertex is 0, 0. And when I move 1 unit to the right, I go up 1, 2 units to the right, I go up 2, right? 2 units to the right, I go up 2. 4 units to the right, go up 4. In fact, I do the same when I go to the left. 1 unit to the left, go up 1. 2 units to the left, go up 2. 4 units to the left, go up 4. Okay, now that's what the shape looks like. Now, why do I need you to memorize this graph? Because then the next thing we will do is to do translation. If I ask you graph, for example, y equals to absolute of x minus 2 minus 3. Let's say x minus 2 first. You will see if we replace the x, if I replace the x here, becomes x minus 2, replacing x by x minus 2, it will move the graph to the right 2 units. So the new graph will be here. Oh, so hard not to make it. Okay, so notice that by replacing that x by x minus 2, it will move 2 units to the right. Okay, this is my absolute of x minus 2, while this is my absolute of x. Now, on the other hand, suppose I continue y equals to absolute of x minus 2, and I continue with minus 3. Now, moving the whole part here, so the absolute of x minus 2 is what I have up there, right? Okay, but then subtracting that by 3, subtracting the whole equation by 3, by 3 will move the graph graph 3 units down. So what the graph look like, if so, then from this vertex 2, 0, I continue to down by 3 units. Okay, so this will be my absolute of x minus 2 minus 3. Two units to the right, 3 units down. Okay, so then what happened to all those informations then? So for example, the vertex originally at 0, 0, originals at 0, 0. Maybe I use blue color. Originally at 0, 0. Yeah, that's good. 0, 0. Now because you move 2 units to the right, it becomes 2, 0. 2 units to the right becomes 2, 0, and then you move 3 units down, it becomes 2, negative 3. Okay, now notice that the axis of symmetry therefore also move. the axis of symmetry for the basic y equals to absolute of x is here, x equals to 0, right? When you move it 2 units to the right, then the axis of symmetry becomes x equals to 2 when you move it 2 units to the right. When you move it down 3 units, the axis of symmetry doesn't move. Okay? So the axis of symmetry is now x equals to 2, originally from x equals to 0. The domain of this function is all real numbers. Now, however you move it then, move left, right, up, down, it will still give you all real numbers. Now the thing is, how about the range? Originally the range is from 0 to infinity. Now when you move it to the right 2 units, it doesn't change the range. It doesn't change the y value. When you move it down by 3 units, however, the range now starts from -3 and on. Okay, so the range right now will be from -3 to infinity. So suppose if I ask, oh, what's the x-intercept, y-intercept? Okay, so the y-intercept, that's actually not hard. You set the x equals to 0, right? Y equals to absolute of 0 minus 2 minus 3. Absolute of -2 is 2 minus 3, that's -1. So the y-intercept should be according 0, -1. Hope you can see it there. That's the y-intercept. 0, -1. Now, how about the x-intercept? You set the y equals to 0, and so for x. We have all the tools to solve that right now. Isolate the absolute value. Absolute of blah equals to 3 implies blah is 3, or blah is -3. So I get x equals to 5, x equals to -1. So my x-intercepts are 5, 0, -1, 0. So you see that my graph and my algebra work actually coincide. This is my x-intercept, 5, 0, and -1, 0. Okay. Now, let me do one more problem. Similar to this, suppose, for example, I want to have let y equals to absolute of x plus 3 minus 4. And the question is, first, find the domain. Second, find the range. The third, the axis of symmetry. And then the vertex. Then the y-intercept. The x-intercept. a little sketch tells us that. So I do my little sketch first. Okay. This is my absolute of x supposed to be. Then x plus 3, replacing absolute, x becomes x plus 3, move it to the left 3 units. And subtract by 4, move it down 4 units. So approximately now it looks like this. This is just my sketch. Okay, now then go back to the question, what happened to the domain? The domain of absolute value is all real numbers. So you can plug in any x you like. Now how about the range? The range originally from 0 to infinity, moving it to the left doesn't change it, but moving it down by 4 will change it. So now my range will be from -4 to infinity. How about the axis of symmetry? When I move to the left 3 units, the axis of symmetry changed to be now x equals to -3, while the vertex now -3, -4. That's your vertex. How about the y-intercept? Well, for y-intercept, I set the x equals to 0. So y equals to absolute of 0 plus 3 minus 4. That's 3 minus 4, which is -1. So the y-intercept is 0, -1. So this will be 0, -1 later. And for x-intercepts, we set the y equals to 0. So 0 equals to absolute of x plus 3 minus 4. 4 equals to absolute of x plus 3. So x plus 3 equals to 4, or x plus 3 equals to -4. X is -1 or x is -7. So the x-intercepts are -1, 0. No, not -1, that's +1. That's +1, my bad. I can miscompute that. +1, 0 and -7, 0. Now part G, what's the graph? Let's try to graph that. I try to put together all the informations here. So my my vertex is -3, -4. It's here. My y-intercept 0, -1. X-intercept is 1, 0, -7, 0. Okay, my axis of symmetry is x equals to -3. So this is my axis of symmetry. Right? Okay, and actually you can also think this way. If this is my vertex, then when I move 1 unit to the right, I go up 1, 2 units to the right, I go up 2. When I move 1 unit to the left, I go up 1, 1 unit to the left, 2 units to the left, I go up 2. Okay, just to give us more points to draw that graph. Now then, I'm supposed to use a ruler, but to save my time, I just connect these points here. And I know the slope here should be 1, 45 degrees. Right, so the graph on the right hand side should look like this, and the graph on the left hand side of that vertex should look like this. Okay. Now, I provide you the basic idea for absolute value. Okay, all you need to know is actually the basic, what the basic graph. All you need to know is what's the basic graph, the blue one here. The vertex is 0, 0. Okay, and then 1 unit to the right, you go up 1, 2 units to the right, you go up 2, 1 unit to the left, go up 1, 2 units to the left, go up 2. With all the domain, range, axis of symmetry, vertex. Now, x-intercept, y-intercept are things you can do by computing. Okay, you can do by computing. Now, using that idea, then we go on to the second type of equation, the graph of equation that I need you to memorize. The second one is y equals to x squared type. Whose graph will be, it has the vertex at 0, 0. And if you go on, that's 1, 1, 2, 4, negative 1, 1, negative 2, 4. You need to memorize at least these 5 coordinates here for x squared. So the graph will be approximately, it's very steep. Okay, the one you need to memorize is 1, 1. Oops. The one you need to memorize is 1, 1. Left and right. 1 to the right or to the left, go up 1. 2 to the right or to the left, go up 4. Okay, that gives you a good framework together with the vertex. Okay, it will give you a good framework together with the vertex. We know it will look like a parabola, but we want to be more accurate for those coordinates near the vertex, and therefore I would like you to be able to find, after you get the vertex, I need you to find the other I need you to find the other 4 coordinates from the vertex. Okay, now why do we want to know this? Suppose, for example, I have this question. Y equals to x minus 2 squared minus 3. Notice that we start from y equals to x squared, and then you move 2 units to the right, it becomes y equals to x minus 2 squared. Remember, when we replace the x by x minus 2, you move 2 units to the right. And then when you subtract by 3, it will move down by 3 units. So the new vertex, the vertex now will be, instead of 0, 0, now the vertex becomes 2, negative 3. Okay. The axis of symmetry, originally x equals to 0. This is the axis of symmetry, right? The y-axis is supposed to be. When you move 2 units to the right, the axis of symmetry now becomes x equals to 2. How about the domain? The domain of every polynomial will be all real numbers from negative infinity to infinity. But how about the range? The range is supposed to be from 0, including 0 to infinity, right? You will never get negative number. Okay, but once you move it to the right two, well, when you move it to the right 2 units, it won't change the range. It will just move 2 units to the right, right? Okay, but there's still the same range. But then when you move 3 units down, then it will start from -3 instead of starting from 0. Okay, so the range now is from -3 to infinity. You can imagine here the range here is from 0 to infinity. When I move 2 units to the right, the range will still be the same because range deals with the y, right? So when you move it left, right, it won't change the y position. Only when you move it down, then the range will change to, in this case, -3 to infinity. How about the y-intercept? The y-intercept, you set the x equals to 0. So y equals to 0 minus 2 squared minus 3. That's -2 squared, which is 1 minus, which is 4 minus 3 is 1. So the y-intercept is 1, 0. While the x-intercept, we set the y equals to 0. I will isolate the completed square. So 3 equals to x minus 2 squared. Apply square root property. Don't forget the plus minus. We learned that yesterday. So if you don't remember that you need to use plus minus, there's only one reason you didn't do your homework. You already have a weak foundation. That's why you don't remember to start with. And you don't even do your homework. So it actually compounded. Then we add 2. So 2 plus minus square root of 3 equals to x. So the x-intercepts will be the first branch, 2 plus radical 3, 0. And then 2 minus radical 3, 0. Finally, let's graph it. Let's graph it. I will graph it here. The vertex is 2, -3. That's my vertex. Let me just do the other 4 coordinates right away. 1 to the right, up 1, 2 to the right, up 4. 1 to the left, up 1, 2 to the left, up 4. Actually, I can do more. 3 to the right, up 9, because 3 squared. 3 to the right, up 9. 3, 4, 5, 6, 7, 8, 9. Therefore, 3 to the left also up 9. Okay, so my graph will be something looks like this. Oh, it's too straight. My axis of symmetry will be x equals to 2. Now, if you don't use your graphing paper, let's say during the quiz or during the test, you cannot print it out, then what you will do is you write down the coordinate. Okay, so you need to write down the coordinate here. You will write 2, -3. This is 3, -2. This one here is 4, 1, right? And this one here is 5, 6. If you don't have that graphing paper, okay, this is 1, -2. This is our y-intercept, remember, 0, 1. Okay, -1, 6. How about our x-intercepts? Our x-intercepts are here. Okay, our x-intercepts here. This is the positive branch. And this is our negative branch. Again, that's you need to write the coordinate and the position on that graph if you don't have the graphing paper. Okay. I will need to continue with that reflection, so I am not done with this reflection yet. I will continue on Monday, but for now, your suggested homework will be what I do here is actually has more to do with what you will see in 2.4 or 2.5. So I have to be honest with you, nothing much you can do for now. Okay, nothing much you can do for now. Maybe I ask you to try to sketch this graph, find the domain range, x-intercept, y-intercept of the following question. Exercise. First, y equals to absolute x plus 3 minus 2. And the second one, y equals to x plus 3 squared minus 2. For both of these equations, I want you to find the domain, the range, axis of symmetry, vertex, y-intercept, x-intercept, and then graph on the graphing paper. Okay, on the graphing paper. Okay, that's where I will stop for today.
Thank you.